Hey guys, here's a video for badge 4 if you're trying to work through it. So I kind of glanced through my notes, and the class we did that was the class of going to prom. All right, and so this is where we kind of hashed out all the steps. And then here's where we talked about our conclusions and what's special about the formula. And here's actually my best chance at, getting all my points right there. So as you're doing, trying to get badge 4, you should work with, something that you have next to you that you're kind of working off of your notes and making sure that you're getting all your points in each component that you've included. So I'm just going to have this little baby one next to me while I'm working through these problems. Now, we're ready to do badge 4. All we need is a fact scenario, right? And that's pretty easy. This badge is merely two proportions. So that means that you asked probably a population of people. So let's say I'm interested in asking the people that live in Ocala, all right? I hear that Ocala is all about horses. So I'm asking the question, do you like horses? And if you don't know where Ocala is, it's on the way to Gainesville, and there's horses everywhere. You just look on both sides of the road, there's horses. And let's say that you might think it may make a difference between old people and young people. So you're going to ask, you think there could be a difference. In fact, if all the fact scenario is asking, is there a difference? Between opinions of children and adults, then in your H sub O, we assume that the two proportions are the same, but you have a sneaky suspicion that they're different. So that would look like this, right? Now, I do want to give this a twist. I'm not sure that badge 4 on the computer has it, but definitely on the AP exam, oftentimes they'll require you to do more than just a one-sided or more than just a two-sided. We should be prepared for a one-sided. So is there a difference between the opinions of children and adults? Let's just go with that. Okay. Knowing that in our prom, we had a sneaky suspicion that one group, this was in adults and kids as well. Yeah, that we thought kids would be more comfortable with their comfort toy. Yeah. And so if you look down here in our notes, that's why we did a one-sided t-test, because of this less than sign. So see how we are going here toward the negative numbers. Yeah, so our fact scenario just says, is there a difference? So that means that I'm going to have to get both sides. This is called a two-sided test because of how they've asked the question. Nice. All right. So we've already started. And it says, is there, what would the fact scenario say? Is there convincing evidence that there is a difference? Okay, and so that's how you know it's a z-test. So if we look at our notes, it says state. We have to define this, right? So we're finding P1 minus P2 to mean the true difference of proportion between children and adults. And remember last time I used the word K for kids. Kids, because I need P combined. Liking horses in Ocala. Nice. Okay, so that's our state. And I have my H sub O and H sub A. And now it looks like I can probably type some things in the calculator and get a kind of a feel for what my outcomes are going to be. So I'm going to follow those steps. Turn my calculator on. Hit calculate. Hit menu. Stats. Stat test. 2 proportion z-test, because I have 2 proportions. Okay, so there, if I look back up in my fact scenario, they have to tell me what happened after you made that request, after you asked people. So let's say we asked, we'll say 63 kids said yes out of 142, and 38 adults said yes out of 84. Okay, so that was the results of our survey, and now we can put that in our calculator here. So if we look at our calculator, it says 2 proportion z-test, x1, so that'll be our kids because we defined the first one as kids, right? 63 in 1, 142, x2, that's 38, into 84. And we're asking, we have a sneaky suspicion they're different. So we'll keep this the not equal to sign. Nice. Ooh, we have a really big p-value. So that tells us that our evidence is showing that there is not much of a difference here. Okay. So looking back, it says I need to state, right? I stated. I need to plan. So let's go ahead and plan. In order for this data and this p-value to mean anything, we have to make sure the conditions are met. So we want to tell the grader what test we think we're doing. So we are definitely doing a 2 sample or a 2 proportion z-test in order to find p1 minus p2. And we have to make sure it's random. So we asked a random independent sample of blank and blank. We look up in the question and make sure it says something like that, and then we can mark that down. We can say in the question, we asked a random independent sample of 142 kids and 84 adults. So we should be good there. Is it independent? We're going to say 10% condition has been met. Because 142 is less than 10% of all Ocala kids. Ocala is, not a tiny town. So it's fair to assume there's more than 1,420 kids there, right? And also with adults, it's more than fair to assume that there's all Ocala adults. And those are the people we're interested in making an inference about. All right. And then our last condition, so 1, 2, last condition is a little meatier because in order to do large counts, we assume just like we shuffle the cards, that the 2 groups are the same. That's our null hypothesis. We assume that they're the same. Therefore, we have to combine their value. Okay, so as we combine them, we notice that we have 63 kids that said yes, and 38 adults, assuming we just pool them together, right? And then we had 142 and 84 adults said yes. So total we had, all right. And that would leave us a p-value combined of, I get this right off my calculator. There we go. So what's happened here? Well, now in order to test normality, I have to make sure that in 1 times p combined is greater than or equal to 10, and in 1 times 1 minus p combined is greater than or equal to 10, and the second group, p combined, and my second population. So let's see what we get here. When I take a look at these numbers, it looks like in my first group, we talked to 142, right? And in the second, we talked to 84. P combined, this would be 1 minus 0.446. And all these look like they're going to be really big numbers, so I think we'll be safe here. All right, and this one would be 30, 84 times 37. Yeah, all these are greater than or equal to 10. So we asked enough adults and we asked enough kids, therefore the sampling distribution should be normal, and our conditions have all been met. Now, with our do, so looking at our calculator, it's already basically done all the work for us. So kind of using my notes here, my do says, I have my general formula, which is my test statistic, is equal to my statistic minus my parameter over my standard deviation. Specifically, my test statistic in a z-test is z, where my statistic is my sample. You know, what was the difference of these two sample numbers? And then what was the difference that you should predict between the two groups? Well, we are supposed to assume that there is no difference. So this would be 0. Here, what kind of a difference did we see between the two groups? So if we look on our calculator, if we look for a difference between them, I'm looking here. So P1 was 0.444 and P2 was 0.452. So there is not much of a difference there. So, okay, so using our calculator, let's figure that out. Yeah, very small. And then for our test statistics, our standard deviation. So that'll be p hat combined times 1 minus p hat combined over n1. Why did I write a plus? This should be a plus sign. Right? We always add variances. That was weird. I wrote that. Brain fart. P combined, 1 minus p combined, all over n2. All right, so what were those values? Well, there's p combined, 0.446 times 1 minus p combined, 0.554, over the first group. That's our 142. 0.446 times 0.554, all over 84. And I'm not even going to calculate this because, again, my calculator already did this for me. I can, though, if I've got some extra time on the test. So I end up getting that. That is my z value. And using table A, or again, just my calculator, from a z value of negative 0.127, we get a p-value of 0.899, or basically 90%. Okay, so what's happening here? Well, here would be the center of our distribution, and essentially I'm only going negative to the left and negative to the right, so the area under this curve is basically almost the whole curve, almost everything under that curve. So that's very likely to happen, not very unlikely to happen. So it appears as if they are the same. Adults and kids in Ocala seem to like horses just as much. Okay, so it looks like we've done all of our parts. Now we're just ready for our conclusion. So let's go ahead and grab this and kind of drag this down and help us along, right? We always want to reference our notes while we're working if it's an open note test. And so we're going to conclude. And so again, a full conclusion, we like to go into talking about our p-value, because our p-value of 0.90 is greater than 0.05, and that's our alpha, unless they tell us otherwise. We have to fail to reject the null hypothesis. Right? We do not have convincing evidence that we go right up to our problem. We don't have convincing evidence that there's a difference between opinions of children and adults about horses in Ocala. Okay. Now the last little bit, I haven't been a stickler about grading this, but it is nice for a complete conclusion. If we're using our notes as well, we notice it says, what does this p-value mean? Well, it's essentially saying, assuming that there is no difference, so p1 minus p2 was in fact 0, there is no difference, or we could have said this, assuming they were equal, said the same way. What we're saying is there's a 90% probability of getting a sample difference. We get a sample difference of almost nothing, right? Or less, purely by chance. So did we get a difference? Absolutely. We got an infinitesimal difference. That does nothing but go to show that they are in fact the same. Opinions about horses in Ocala is essentially the same. But by chance, of course, when you ask people stuff, one group might be slightly larger than the other, even if they feel pretty much the same about the topic. Thanks for joining us, guys, for Badge 4.